Okay, we're in sections 5.6, which we just learned about using the law of sines. And now we're going to say, okay, how do we use the law of sines, or how do we use that and to find area of triangles? And we're using some different formulas here. Okay, and so really, this really is a lot about the formulas. So it's going to be the whole point of this is using a formula and understanding the law of sines to find the area of the triangles. And it's really a big part of this is using the formulas. The law of sines will help us a little bit to find some of the missing sides if that's the case. So the formulas are on the yellow sheet, and you're going to be allowed to use the yellow sheet on your test. So I gave this out earlier. Area formulas. The first one we need is the K. K is always the area. So when we're talking about the area, we're talking about the letter K. So one is that the K is 1/2 of AB sine C. Another one, 1/2 BC sine A, 1/2 AC sine B. If you notice in any one of these, like here in sine B, we don't have side B, but we have angle B. So when we're using this is when we have one angle, all right, we're given one angle, and the other two sides. I'm going to call them the other two sides. So not the side across from the angle, other two sides. When we're given all three angles and only one side, then we're going to use this particular. So when we're given three angles, or two, because we could always use the 180 rule to find the third, and only one side. Okay, that's when we're going to use this second formula. So it's going to be a lot about just how do we replace the formulas, and then how do we kind of plug in our numbers and chug out an answer. So when I'm looking here, we're given an A, we're given a B, and we're given a C. Now for the most part, we could say, okay, let's draw this triangle. So if I drew this triangle, I could say A, here's B, here's C. And then A would be 21.2, B is 12, and actually I drew my triangle incorrectly, but that's okay. C is 25 degrees. So we could try to figure this out and draw right angles, and it's really kind of gets confusing, kind of gets really involved. I think a much better way is to use the formulas, and that's why we're going to be really, this is all about focusing on using a formula. It has a lot of applications using a formula in science as well. So if you've had a science course, either chem or physics, it's really going to help you. So the one formula that I think I'm going to use here is this 1/2 AB sine C, because we have A and B and the angle C. So I'm going to say my area is 1/2, and we're going to take the A times the B, and we have sine of angle C. Okay, well, I know A here is 21.2. I know my B is 12, and I know my C, I'm running out of space here, is 25 degrees. Really, what we're looking at doing here is using a calculator to complete this. So I'm going to go to my calculator. And if you remember, what we had is we had 1/2, I'm going to say that's 0.5, times 21.2, if you remember, times 12, times sine of 25. So sine of 25, and there's my sine of 25, and I enter. My answer is 535.5. So I'm going to just go back here, 535.5. That's my area, all right? That's really what's going to be involved with this, is over and over again, just how can we kind of plug it back into our calculator. Let's look at another example here. All right, so now with this example, we are given an A, but this time we're given an angle B and an angle C. And that's how I know that, because of the capital, A and the capital C, okay? Again, for these, writing them out isn't going to help. But what I think that I'm going to be using, and I'm going to kind of show you up here, that's why I kind of had to roll down, is this formula here, where my K now is going to be equal to 1/2 times my A squared, and then we're going to take the sine of my B times the sine of my C angle, and I'm dividing it by the sine of my A angle. Now, you're saying, but they didn't give me the A angle. But we know we have a triangle here, and that the angle of the three angles of any triangle always add up to 180 degrees. So I'm going to go here real quick, and I'm going to calculate 42. So my last angle, my angle A, would be a 42-degree angle. So we do have all three angles. All right, so let's see, how would we kind of plug those in? I'm going to say 1/2 times my A, 45.7, squared times the sine of my B, the sine of 111, times the sine of my C, the sine of, oh, not 42, excuse me, the sine of 27, all over the sine of A, the sine of the one we calculated, 42, okay? Now, the one thing I would tell you is it's okay to try to put these all into the calculator in one order, in one group, okay? It's just at the end we have to be careful a little bit with our signs that we have parentheses around our signs. But that's really the only thing that would bother me because we're dealing with all multiplication and division. So if you remember, we had 0.5 and it was times 45.7 squared. So that's 45.7 here. I am squaring it. And then that was multiplied by the sine of 111. That's 111. And the big thing I have to do is say, okay, I end my parenthesis there. And I'm going to multiply it by the sine of 27. And my parentheses, that's really important. And then I was finally dividing it by the sine of 42. My final answer, 661.4. So that's going to be my answer there, is that my K here is equal to 600, oh, now I got to even remember what I had, 661.4. All right, that is the area of this particular triangle, of triangle ABC. It really doesn't go much more involved than that. I mean, it changes back and forth what I've been given, um, but it's the same type of problem, all right? Let's go through this one. Again, I'm going to use my last equation for this. My K here equals, in fact, why don't you just go ahead and try to solve this? I'm going to go work it out here. 0.8 squared times the sine of 15 sine, I'm going to leave that blank for now, over the sine of 34. Okay, I have to calculate what is my C. Okay, so I'm going to take 180, I'm going to subtract off 34 and subtract off 15. So I got 131 for my missing angle. All right, go ahead and calculate it, see if you get what I get. I got 33.3 for my answer there for K when I multiplied it and put all that into my calculator. So the assignment that I attached to this is a good assignment. It has some good word problems in it too. And so we'll be looking at some of the word problems here. In fact, we might look at one of these. For some of these, we really want to kind of show this and like have it like, I want to have a, let me see if I can cut this out. Let's see if I can do this. We're going to want to show a visual sometimes on this one. All right, let's see if we could do 28 here together. All right, so there is 28. Okay, so you're asked to do 19 through 24 and 28. Let's just talk about 28 really quick. A landscaper wants to plant begonias around the edge of a triangular plot of land. All right, we have a triangle. We want to have flowers along that. Two of the angles are 95 and 40. I'm going to make this 95, this one 40. Okay. Again, it really doesn't matter what we have. We have an A and a B. The side between these two angles is 80 feet. There's my C. There's what I'm missing. All right. Long. Find the measure of the third angle. That one's not so hard. We just use our 180 rule for that. 180 minus 95 minus 40. I got 45 for my missing angle here. So my missing angle is 45 degrees. All right. Find the length of the other two sides of the triangle. Well, now actually for the other two sides, I could be looking at law of sines on this. Okay. So for this one, it would be more, I think it'd be, this one is just one where they're just looking for what's the length of the side. So we're no longer are we looking for or saying, hey, we want the area. This isn't asking me for area. It's asking me now for these two sides. So this is actually one where I'm going to go back and I'm going to use law of sines. I'm going to say 80 over 45 equals the missing side B over 40, and it's not 40, sorry, I misspoke, sine of 45 and sine of 40, okay? So my B here would equal 80 times the sine of 40, and we're dividing it by the sine of 45. Okay. And then we can figure out our B, and then we're going to do the same sort of thing to figure out our A, our missing side right here, which is our A. We're going to use the law of sines again for the A. Then the perimeter that they're asking me is just simply, what's the distance all the way around? Add your A, add your B, add your 80, and you can work that out. So I just want to give you kind of a head start of how do we solve this word problem. Thank you and good luck.